Making research effective and reproducible. The pufferfish case. The pufferfish, Lagocephalus sceleratus, is an invasive species that has entered the Mediterranean Sea through the Suez Canal and is favoured by climate change. It attacks nets and fishing gears, is highly toxic and thus dangerous if eaten, and has a serious negative impact on the Mediterranean countries. For example, Turkey has estimated a €5 million loss between 2013 and 14. Thus, policymakers have deep interest in understanding where this fish will be in the near future. The goal of our multidisciplinary team of scientists was to predict the areas this species was going to invade in the near future, and also to do it in a way that the approach was reusable, repeatable, reproducible, and applicable to other alien and invasive species. Collaboration between us was challenging too, because we were located at different and geographically distant institutions, England, Spain, and different cities in Italy. For these reasons, we technically needed accessing multiple and heterogeneous datasets collected by different organisations, data processing solutions using large computational infrastructures and offering appropriate algorithms, services supporting collaborative science, and services that allowed comparing our results with other scientific results. In order to address these requirements, we set up a virtual laboratory named Alien and Invasive Species that connected heterogeneous services provided by several European infrastructures, Sea Data Cloud, D4Science, EGI and Copernicus. These services covered the complete cycle of data analytics, from data collection and preparation to results publication, and supported collaboration and data exchange. Using them, we retrieved environmental geospatial data and species observations from GIS data provisioning services. Then, we combined a number of artificial intelligence models to estimate the correlations between the environmental data and the observations in the species' native habitat, and we projected this correlation onto different subdivisions of the Mediterranean Sea to display potential risk. Finally, we published these maps in infrastructural repositories and compared our results with recent observations of the species in the Mediterranean Sea. Our results highlighted a westward decreasing impact pattern where high-risk zones for fisheries and health security are present in the eastern Mediterranean Sea and also in some areas in the middle and south, with a particular alert for the Bosporus that opens the way for the fish to enter the Black Sea. Overall, we advised selective fishing in the likely future impacted areas. These results were described in an open access publication that has been deposited in zenodo.org and that is then accessible also through OpenAir. All the services we used are now discoverable and accessible through the EOSC portal so that they can be used to predict other dangerous invasions, like the one of the lionfish in the Mediterranean Sea and US waters. The EOSC portal also allows accessing the Alien Invasive Species Virtual Laboratory to quickly replicate our results and apply our methodology to other species. Thus, by leveraging the multitude of EOSC services, we made our research fully compliant with open science practices in the sense that we collaborated through the EOSC services. Every step is repeatable, the data and processes are freely accessible through standards, the experiment is described through an open access publication, and the approach is general enough to be applied to other invasive species. The availability of these services allowed us to deliver a scientific result that had never been produced before, in the short time frame of 1 month, which was unimaginable in the past. If you are interested, I invite you to go to the EOSC portal, enter the virtual lab and replicate our experiment.